So in previous 2 sessions, we have learned tools and the general procedure for the application and analysis of vector and raster dataset, respectively. And what we have done is similar to what we would do in real GIS project. And in reality, actually getting the final result in GIS data format is not the end of a project, because we're not doing the project for ourselves. We have to present the information we extracted from the from GIS. We extracted from spatial analysis to wider audience, and they might not be the expert in GIS or geography. So that is necessary. That is necessary for us to find a proper way to represent our result, and so that we can promote the value of our work. So traditionally, this goal is achieved by cartography, or in simpler words, map making. And so that's what we are going to do today. So in the first part of the session, we will have a quick introduction on basic map knowledge, including the principles for map design and the general procedure of map production. Then we are going to design maps in SuperMap iDesktopX to present key information we produced in the demo of last week. And we will assign proper symbols for different layers, and also create necessary thematic and label layers to make a concise map that is easy to read. And finally, as we all know, an informative representation of a GIS project should consist of both the map body and some complementary elements. Okay, so now let's still start with the discussion on basic map knowledge. So map always play an important role in the communication in human history and daily life. So since the ancient times, people in various cultures and places have drawn maps of their land and the oceans by hand, like this one you can see here. And although these maps are not as accurate as the maps we have today, they are still essential tools in social activities, and it's the same nowadays. So most commonly used GIS application like Google Map and Uber, they both use digital maps to show basic information of an area, and the system behind these maps would conduct the calculation and analysis according to user input and spatial data in the map, and eventually the routes planned by the system would be shown on the map as well. So here we can see map works as the base and representation of spatial information in such sophisticated geographic information system. And on the other hand, as we are GIS experts, we not only use those commercial GIS system, we would also doing our own GIS project, and really we would create and design our own maps to demonstrate our work and discuss it with the others. So here are some examples of model maps designed by GISer. So for instance, here we can use symbols with varied colors and size to show the number of visitors to each national park by month, or we can, or we can create a beautiful and cute map like this one in hand drawing style to show the population distribution of penguin. And also we can create a very straightforward but impressive 3D maps to emphasize the magnitude of polar heat, like this one on the right. So all the design and creation of these maps really involved application of a lot of tools, but basically they should follow the general principles of the use of principles for map usage and map design. So now you should have no doubts on the significance of maps in the communication and decision-making process in varied fields. And in our GIS project, we would done a lot of work by ourselves, like data collecting, editing, and analysis. And you won't show all this process to others that is not an expert for GIS. Finally, the result you represented to others should be your final map. And so here, map is the representation of all your hard work, and the design of your map would partly decide how the others would have a first impression on what you have done in your project. So here we have some helpful suggestions on what to take in consideration when you are doing map making, and so that you can give a better impression to the others. So here we would recommend you to keep this at least these 6 principles in mind when you are designing your map and when you are designing and making your map. So the first is purpose. Are you going to show? That means you should consider that. You should consider what you need to consider first is, are you going to show the general information of an area in only one map, or do you want to highlight a specific kind of features in one area? So the way of map design should be varied based on your purpose. If you only want to present general information of an area, then you should design a reference map, and all the features on that map and all the features on the map should be equally presented, and you won't highlight you won't highlight only parts of them. And on the contrast, if you want to highlight something, then we are going to create a thematic map. And in thematic map, only the features we are interested would be highlighted, and all the other informations would work as a background information. And then the second thing we need to consider is the scale of mapping. If you are using small scale to cover a large area, then it's better to drop some detailed information so that you can make sure all the features on those features on your map won't cluster together. And when you are using large scale to focus on a very small area, then you can keep more details, and there are more choices for you on symbology. And then we would go to the third principles, that is symbology of your data. So here you should choose the symbology based on a full understanding of the data you want to present it, and so that you can choose the best symbol to emphasize the feature, to emphasize the characteristic of the features. And for the design, for the overall appearance of your map. So here, of your map. So here, you need to remember always create a visual, create map that is visually pleasing. That is to say, you can improve the visual appearance of your map by adjusting the contrast, legibility, or the organization of layers and elements on your map. And then the next principle is about the audience. So here, the audience means when choosing which information to express in your map, you need to consider whether the information you have chosen can be easily understood by ordinary readers, or if your readers have enough time and knowledge to comprehend the abundant information. So, for example, the maps you created for the Sim project would be different. You should have a version that is presented to the ordinary public, and then you should have at least one detailed version to present it to GIS experts, so that you can have a better discussion on your work and what you have done. And finally, the use environment and display media could affect the design of your map as well. If your map is going to be printed on paper, then you should consider the size of paper and colors of ink you can use, but you don't have to worry about them if you are creating a digital map. So keep all these principles in mind, and now we can start the procedure of map making. So here today, we're going to use the data we produced in last week, which is for the project of Southeast region in Brazil. And that means we already have completed the first part of our work, data prepare, that including collect data, edit data, and conduct some necessary spatial analysis. And so today, our first task is to assign proper symbols for the data we want to present to others. And we can do that by set the layer styles, or produce some new label layer or semantic layer. And we can, this is what we're going to do in the second part. In the third part, we would add some complementary elements to make a complete map so that it can be presented to a wider audience. And now let's first to say how to let's say how to design and create symbols for our features in SuperMap iDesktopX. So here, as you might already know, in previous sessions, we have prepared a series of symbols in SuperMap iDesktopX. And if you want to see them, you can go to Workspace Manager, and then under Workspace Manager, find resources. And under resources, you can see we have 3 symbol libraries. And the first one is for our point features. The next one is for line features. And the last one is for polygon features. And if you think all these features we provided for you are not inadequate, if you think those symbols we provide for you are inadequate for your project, then you can directly create your own symbols in SuperMap iDesktopX, or edit some symbols, or edit some already exist symbols. Or you can create symbols, use other software, or download symbols created by others from the internet, as long as they are in PNG format or SVG format. Then you can import them into SuperMap iDesktopX as well. So now I will simply show you how to find all the symbols we have in symbols library, and add them or import new symbols. So here in our software, under Workspace Manager, you can find the last node is called Resources, and under it, here is 3 symbol libraries. If you double click on one of them, then you can, like here, we have opened the symbol library for for our point features, and you can scroll down to see all of the symbols we already designed based on those are most commonly used symbols when you are creating maps. And if you don't like it, if you don't like this one, you can import if you want, like here, we can select each of them. And here you can see some of them cannot be edited, but some can. Because, for instance, if you choose this red dot, and then you can find here is a button activate. Here is a active button on the top, and that's called edit symbol. Then if you click on it, and in this interface, you can edit this symbol as you wish. Or if you want to directly create your own symbol, here on the left of edit symbol, here is an option called new 2D symbol. Simply click on it, and then you can use all these tools under interactive edit to create your own symbol. Or if you would like to use other softwares to create your own symbol, or you have downloaded symbols created by others, still you can import the symbols by click on import symbol or import raster symbol. Import raster symbol is used for PNG file, and if your symbol are in SVG format, you can use import SH format. And that's all you need to know about where to find the symbol libraries and create or edit your own edit symbols. And then let's talk about how to symbolize our features, use all the symbols. So actually for symbolization, there are 2 ways of symbolization, uniform and semantic. Uniform means for one data set or for one layer in SuperMap iDesktop, all the features in the same layer or the data set should use the same should be visualized, use the same type of symbol and color. So there's no differences between the features in one data set. And then actually in the application of GIS, maybe we preferred to show the attribute or the property of those features by using different colors or different size of symbols. And so in that way, we would create semantic layers so that we can see features under one category would use green symbols, and features in category 2 would use orange symbols. So it is easily for us to visually interpret the property of those features. And so here we have listed how to set uniform layer style, or how to set symmetric layer style. It's easy to do uniform layer style. You simply add your data to your map window, and then you select its layer, and you could find a style tab on the top of the software, and here you can set its style based on the type of the features. If it's point data set, then you need to set marker style. For line data sets, it's line style, and for polygon data sets, it's fill style. Or you can directly in their manager select the layer you want to change its style, and right click, and then choose layer style. And then on the right side of the software, here would open a window called layer style, and you can also set the style for this layer under this window if you want to see if and also you can click on this button on the left or right, so that you can open the symbol library and to choose from all the series of symbols for visualization. And then for semantic layer, that's kind of different. Still, you have first add your data to your map window, and at that time, there will only be one layer, a uniform layer for the data set. But then on the top of your software, you can find that there is a tab called Symmetric Mapping, and under it, you can choose which kind of semantic layer you want to create. Or after you add your data to the map window, you can still go to Layer Manager, select the layer, and then right click on that layer, and under it you can see there is an option called Create Semantic Map. And then if you click on it, it will open a new interface. And under it, you can choose which kind of semantic layer you want to create. And here by default, we have about 8 times. We have about 8 kinds of semantic layers can be created, and we would have a further explanation on each kind of semantic layers. So here's a list of all the semantic layers you can create it in SuperMap iDesktopX. The first one is unique value. That is usually used to show to visualize your data set based on different categories. Like for instance, we could assign different type of symbols for different kind of roads based on excuse me. For instance, we can assign different symbols to different kind of roads. Like here, you can see on this map, and that is based on the type of the roads. And then you can specify which columns in the attribute of your data set contain the unique value you want to use for visualization. And then the second type of semantic layer are range value that is used to show the that is used to assign different symbol to assign different colors to continuous values. Like here, we have created a value range semantic map for the population density of China, and you can see the higher the population density is for an area, the darker the color assigned to it. And then sometimes maybe you don't want to show the information in your sometimes maybe you don't want to show the information in your attribute table in an implicit way, like here using different symbols or different colors. You want to directly show the text information in your attribute table. So then you can create label layers. Here, label layers could also be a kind of semantic layer as well. And then for raster data set, also we can have, and then for raster data set, similar to vector data set, we could create range semantic layer for raster data, or unique value semantic layer for raster data as well. And then we can also create statistical graph layer for our data set. Usually we would use this kind of semantic layer to show information in multiple columns in the attribute table at the same time. So like here, we created a statistical graphic symbol, here we have created statistical graphic layer to show the proportion of population in each province of China. And the next one we can create is graduated semantic layer. That kind of layer uses the size of symbols to show the quantity of value. Like here, more population, the larger the population value is, the higher the population value, the population for the province, for a province, the larger the symbol is. And similarly, if you don't want to show your data, if you don't want to show the quantity of values using this kind of points, using this kind of point symbols, you can also choose to create aggregation semantic layers. So here, aggregation semantic layers is specifically used for polygon features, and it will fill a given area with equally distributed dots, like you can see here in this example. And although the distribution of these dots are equal inside each of these features, the number of dots depends on the quantity of the values. And now let me see if you have some questions now. If you want to join your calculation result from other software, it's okay, because you can save your calculation. You can save your calculation results as let me see. Save your calculation result as Excel file or CSV file, and then you can add that calculation results, import those spreadsheet into SuperMap iDesktopX, and then you can join it or connect it to spatial data set, and then you can create those symbols from it. And for 3D symbology, yes, we have 3D symbols if you have 3D data. Because in this webinar, we would concentrate it on 2D data set and 2D format and 2D symbols as well. If you are interested in 3D, if you are interested in 3D data or 3D application, you can see the playbacks of our training cap for last year. Okay, then here's a question about the decimal places for symbology. Maybe you can further explain your question for the decimal places for symbology in your in Q&A or in email. Like for our data itself, the decimal places you can have is based on the type of it's based on the field type you designed for it. And if you want to directly show those numbers on your data, show the numbers on your map, maybe that's on the settings for label layer, and we will create our label layer later. And then we will have a quick introduction, a further introduction on label layer we would use when creating maps. So we would use labels to communicate or show attribute information in our data set. And when doing that, we need to keep in mind that we must play our labels near the features it associated with, so that won't cause any misunderstanding for the interpretation of the information. And then actually there are two ways to create labels in SuperMap iDesktopX. We can create semantic label layers, as we said before, and by doing so, we could produce a large number of labels at one time, and as label layers are created from our attribute tables, once we change the information or records in the attribute tables, the content of our label, the content of our semantic label layer will automatically update as we have done the changes. But there's there are also some disadvantages for semantic label layer. For instance, all the labels in the same layer would use a uniform style, and sometimes there are overlaps between the labels, and it's really hard for you to avoid them. And then, so the other solution for the other method to add labels to your map is to create text data set. We have used text data set in the first two sessions of this webinar, and you can review them if you want, if you like. And if you create a text data set, then you can set the content and location for each of the label one by one by yourself, and each of them could have different styles. But as you can imagine, it will take a lot of time and effort to create and edit text data sets by your own. So here in today's demo, we would only use semantic label layer. And here are the general procedures for the application of text data set and semantic layer data set. So you can simply have a comparison if you wish. And so now here we would have a 5-minute break, and then we would come to conduct our demo, that is to present the result and the factors we used for landslide susceptibility assessment in southeast region of Brazil. And before we go to a break, here you can see that here is a notice that because we have already done the project in last week, so that you can use the result and data set created by yourself. And if you don't have those results, it's okay. We have included them in the materials for today's session, and you can open this data source called landslide, and here are all the data sets we're going to use for today's map making. And so now let's take a 5-minute break, and let me see if you have any questions now. Any questions so far? Okay, now it's time to create our own map. So let's go to SuperMap iDesktopX. And as we have said before, today we're going to use the map we already create. We're going to create maps to show the work we're already done for last session. So first we need to connect to the data source. So here under Workspace Manager, go to data source and then right click on it, choose open data source. And then we can go to where we have saved the materials for 5th session. And then you can select the data source called Brazil Southeast and click open. So inside it, you can see that's all the data sets we are going to present today. So we can show the land cover type we used as analysis factors in previous project. And also there are other factors like slope or precipitation and the distribution of rivers. And no matter which factors or results we're going to show, always remember we need to tell our audience where are our study areas and the state names for those study areas. So first we need to. So our first step is to have proper visualization for the border for the boundaries of our study area. So select the data set called Brazil Southeast and then double click on it so that we can add it to our map window. And because later we would add our factors and analysis result to this map. So actually we don't want there to be any colors in this data in the visualization of the boundaries. We only want those boundary lines. So to do that, we can change the layer style for this data set. So here under Layer Manager, select this layer and right click, choose Layer Style. Here you can see that on the right we have opened a window called Layer Style, and here now we're using system 0, this kind of symbol, and we can see that system 1 for this kind of symbol we have no fill color in designed for this kind of symbol. There are we can only show its boundaries. So that's exactly what we want to use. So change this one, we can see the style of this layer changed directly. And then under it, still we can set the color of the line and the width of the line as well. Here, we would set it to be 0.5. And if we make the layer style window larger, we can see that the unit for width is on the right. So if we are curious about it, that's how you can see it. And then we also want to show the name for each of these states. And to do that, we can still go to Layer Manager and right-click on this layer, and then select here, Create Symatic Map. And here, as what we want to do is add labels to show the state name of each of these states. So here we would choose to create semantic layer, to create label uniform semantic layer. And for the style, we would choose the default and then click OK. So here we can see we already add some labels to this map window, but it's not the name of but those now the content of the label is not the name of each of the state, and we need to change them. To do that, first make here on the right, it automatically open a window called Symmetric Mapping, and you can set the parameters for your semantic layer under this window. So first we need to make this window larger. And then you can see that we can here under the property of this semantic layer, we can change the expression. Here, expression means which column of the attribute we want to show as a label. So here, now it show name 0, and that's the name you can, and that's actually the country name for our study area. So here we would change it to name 1. And now immediately you can see that is the correct name for each of the state. And then also, if you want to change the style of this label, here still in the Symmetric Mapping window, here you can see actually we have 3 tabs. Under properties, we can set which columns or which columns of the attribute table we want to use for the label expression. And then if we want to change the style, then we can switch to the tab that is called Style. And under it, we can change the font we used for this label. And also we can change its size, like we can set it to be 12. You can input it and then press Enter on your keyboard. And also, I would like to, you can see at the bottom of this, window, we can also set some font effects. So here, I would like to add some streak outline. Oh, sorry. I would want to add outlines for these labels. Just click here, and I can set the pixel for this outline and also the color of it. To change the color of it, you can see it's on the top of font effects. And here I would like to change that color to be white. That's how it looks now. So this is the basic map to show our study. This is the basic information we always want to keep and show to our audience. And then we would want to add more information like the factors we used for analysis and our final result into this map window. So the first factor we want to add would be this raster data set that is the slope of the study area. So here we will select it and then right click on it. And then we can choose add it to current map. Now it is added to our current map window, and it's overlaid on the state boundaries. And so we would want to show state boundaries over this slope layer. So on the layer manager, we can change the orders of this layer by select one of them and then drag. So now I have put slope at the bottom of at the bottom in layer manager, and so that would be how you want to present the slope factor you used for analysis to your audience. Okay, that is a very simple map, and that's all we need to do to create the map for slope. So we can right click on it so that we can, and here choose save map. And here we would give it a name as slope map and click OK. So once you saved it, here you can see in Workspace Manager under Maps, here we have slope map. And if we close this map window, and then we would want to see what we just created again, you can directly open slope map under Maps. And that's exactly the same. And once you save this workspace, then you can always, this map would be saved into the workspace as well, so that you can always open it again. So here we would save this workspace as well. So to do that, you can go to the top left of the software and find the save button. If you click on it, then you are going to save the workspace, your current workspace, and you can save it to wherever you want. And here I will save it under the folder for material 5 and name it as map making, and click save. Click OK. So you won't lose. So by doing so, you won't lose the maps you created by yourself. And now we would create another map for the rivers in our study area. And so here, as we said before, we want to keep those state boundaries and also the name of states in all the maps we created for this project. So here we can still keep this map here, and then right click, and then we can select save as map. So we can save this map as another map in the workspace, and we will name it as river map and click OK. Now you can see here the name of this map window have changed, and that is called river map. We also have it saved under maps. So now this is the map we would want to create for river. And so we would delete the layer for slope first. So select this select this layer and then right click then you can choose to remove it. Click OK. And then we would add layer feature. We would add river features to this map. So here we have two data sets for layer. The one of polygon river features, and the other one of line river. The other one is line river features. Select both of them, and you can directly drag them into current map window, like you can see here, or you can right click and choose add them to current map. Either way is okay. So here, then we can set the symbols we're going to use for each of them. Like for river, for the line feature of rivers, we would select water L, this layer, and then you can go up to the top of the software, and here is a tab called Style. Select on it, and here on the line style, you can quickly set the style for this layer. So here, first we would change the color for it. We would use a brighter and lighter blue, and then we would want to change the width of it to be 0.2, and push enter on your keyboard. And that's all we need to set for this layer. And then under Layer Manager, we can select water P, that is polygon features for river, and also we can set the style for it under Style Type. And here, we're not going to set line style. We are going to set fill style because this is a polygon data set. And so here we can directly change the foreground color of it. That should be a bright and light blue, but kind of different from the color for lines. And then if we zoom in, we can see that now the lines for this shape, the lines for the fill symbol of this data set, its color is still black, but we want to change the color of these polygon lines to be blue as well. And if you want to do so, under Fill Type, click Fills, and then click More Symbols. And then that would open a more detailed setting interface here. And under it, here on the right, you can see that not only can we change the fill color of this symbol, we can also set light symbol for this fill symbol. And so here, click the button beside the light symbol. And now you can see that we can change it to be different styles of lines, but we don't want to change it. We only want to change its width to be 0.2 as well, and then change the color of it to be bright light blue, and click Apply. Click OK, and then click OK. And now, if you zoom in, you can see that the outlines of those polygon features are blue now. And now let's zoom to full extent of our boundaries now. And then to make it to be a nice map, we also need to change the layer orders. So here we would put the layer symbols at the label layer on the top. And that's all we need to do for river map. still right click on it and choose to save map. Now, what we have done for river map have saved. Let's first close this map window. And here we can see in Workspace Manager, we have two saved maps. The first one is slope map. Double click on it. Then we can see that's how we designed it and save it. And then we can double click to open river map. And that's how it looks like. And that's what we want. And the next step is to create a precipitation map. And here we're going to create, we're going to show the audience the ISO region of our precipitation calculation analysis result rather than the raw precipitation rasters, because it's easier to read a ISO region result rather than a raster data set. And so here we would simply, as what we did for river map and slope map, we would create the data set. We would create the map for precipitation from this river map. So here we would simply right click and select Save as Map and save it as Precipitation Map. And click OK. And then under Layer Manager, we can remove the layers for river features. And for precipitation map, we would not only show the precipitation ISO region, but we also want to present the raw data set we used to calculate precipitation for the whole study area. That is the precipitation records for our from our weather stations. So we can select these two data sets and add them to current layer and add them to current map window. And then first we can do a simple task, that is to set the symbol for weather station and select it, right click on layer style. So here I don't want to show them with this circle circle dot. I would like to show it with this square dot. And also I would like to change the color of it to be gray. And that's how I would like to visualize the location of the weather station. And then I also would like my audience to see the this precipitation map, and they can directly know the precipitation record for each of these weather stations. And to do that, we can create a semantic label layer for precipitation station. So here I would right click on it and choose create semantic map. Here still that should be label uniform map, and choose the default style and click OK. And here still under property, I would first change the expression of it, as I want to show the audience the record of annual precipitation for each of these weather station. So that would be, so the column I want to use for expression is annual precipitation. Now that's changed. And then here we can see that under effect settings, we can set how to avoid overlaps here. So we have set it to avoid overlap at 4 directions. And if you click on it, you can also set it to avoid overlap at 8 directions as well. Just either way, you can set it by yourself. And then the next step is to set its style. So go to the tab of style under this window. I also want to change the font set for it. And then about the alignment, there's a lot of settings we can set. Like I would like to put it as top center. And also I want to make it kind of smaller. So I would set the size for it as 9. And add outline to it and set the outline color to white. So that's all I need to do for weather station themselves. Then it's about how to visualize this precipitation isoregion. So here we can see it is not suitable for uniform styles. We would create it's better for us to create a Symatic map for it. So here we would select precipitation and layer, and right click on it and create Symatic map. And here we would like to create a ranges map, and the style should also be default, and click OK. And here now you can see that it uses the color scheme it used is a red color scheme. But as we're going to show precipitation, it's better for us to use some sort of blue color scheme. So to change it, we can go to Symmetric Mapping window, and here we can change the color scheme. And here I would like to use this one. Now it looks better, and also we can change the message for. We can change its classification message and the range count. Here I would like to change it to quantile interval, and the range count I would set it to be 6. And that's how we can create a range value Symatic layer, and set its parameters and styles. And also here's another thing, because we have black outlines for our state boundaries, and so here we would like to make the outlines for our precipitation layer to be white rather than blank. And to do so, we can set it also under Symatic Mapping. And here we can see that these are styles for each of these categories or symbols. If you double click on one of them, you can you can change the if you double click on one of them, you can set the specific symbol for this kind of category. And here, if we want to set the outline color for all of them, we can first select the first one, and then press Control button on your keyboard, and then click on the last one. Then push Shift button on your keyboard and select the last one. So now we have selected all of them, and then we can set the style for all of them by 1 altogether ones. To do that, here on the top of them, you can see here is a button called Style. Click on it. And now here we would click on Line Style. And also under Fill Style, we would click on Fill Symbol. And then click Next. And now, similar to what we did before, still we can specify, we can see that on the right, we can specify the light symbols we desire for this fill symbol. So here, click on light symbol. And the only change we need to do is to change its color to be white and click OK, then click OK again. Now we can see the fill color of all these features on precipitation layer are not changed, but the outlines have all been changed to use white color. And that's all we need to do to set their styles. Now we can adjust the layer order for this map. So still we would put the boundaries for this. We would put the boundaries of state boundaries on the top, and also the label for state name on the top as well. Now that's how we would want to make, that's how it looks like. And now we can still save it, simply right click and save this map. And then our next step is to create a land cover map. So, okay, let's zoom to the full extent and then save map again, and then choose save as map. We will save it as land cover map. And then click OK. And now we will remove all the layers associated with precipitation. Just select them and then click remove and click OK. Now we would add the layer for land cover, and that's under select it and drag it to the window. Now in the layer manager, we can click on this layer, click on this small triangle button before this layer, and we can see this is the color scheme used for it now. And it's okay to use it, but as you can see, it's really a mess and you can't tell the meaning of the category simply from its color. So for better visualization, we can create a unique value semantic layer for this raster data set. Simply select it and then select create semantic map. So here, grid unique values, that is the semantic layer for raster data set, and then click OK. And now it automatically designed, assigned a color scheme for it. We can change the color scheme here. And under properties here, you can choose from them. And if you don't like that, usually, if you know the meaning of each of this color category, of each of these, if you know the meaning of each of these value ranges, and then you can double click on the style of each of them and change the color of them one by one. And here, due to the time limit, I won't change them here during our live session. If you are interested, you can go back to it, and here we have a hint on how to set the color scheme for this land cover map. Here on the very right, under caption, that is the meaning of each of these categories, and you can assign color for each of these categories. For each category based on its meaning, and that's what I created for land cover map. And you can use your own based on your principle of design. And now let's go back to our software. Once you have set all the styles for all the categories, then you can change the order of the map, and you can delete the original map. If you are satisfied with this kind of style, then you can save it. And then we can go to create our next map. So here we would right click again, choose save as map. And the last map we're going to create is our landslide. Susceptibility map. Click OK. And then we would remove the land cover. Hello, can you hear me? 可以听到吗? Okay. Okay, now let's continue. So here, as we said in previous session, for our results, we only want to show those areas with high or with high and relatively high vulnerability to landslide hazard. And so we would want to add some background color for the whole study area if they are not if they are not very vulnerable to this hazard. So here we would change the style for our study area boundaries. And so here we can select this layer and right click on it and choose their style. So here we would change the symbol to be system 0 and change its foreground color to be a light gray, like this one. And then here we would add our final result to this map window. That's how it looks like originally. And then as what we did for the layer, what we did for land cover layer, we would also create a Somatic map for this raster data set. And here we would choose to use unique values as well, and then click OK. And then here, because we're not interested in areas with low susceptibility to the hazard, so we would simply make them invisible. And to do so, we can see that on the very left, of each of these categories, there is a little icon, looks like an eye. You can click on it, then we are making one of them invisible. And here, for those with values of 0, 1, 2, we would make all of them invisible. And now you can see that although values we're not interested are invisible now, but they look great, but they look as no value data, and it's with white color. But actually we would want to make it transparent. And to do so, here under the spatial style, we can check to make spatial value transparent display. Once we click on it, and then we can remove our original layer for landslide for the result. Here, select this one and remove it. Okay, so now we can see that the semantic layer of landslide susceptibility is partly transparent, and where we are interested in the analysis result is perfectly overlined on the boundaries of our study area. And then we can still change the values change the color for these visible categories. We can keep the light red color for category 3, but for category 4, we would want to make it to be very bright red color, and that might take a little time for the software to process. Okay, now that's how we would like to make it. And now we can put the label layer at the top as always, and that's the result map for our final result of the project. So we can save it, and now we can see we have created 5 maps, and all of them have been saved. And our next step is to create a layout. And now let's go back to our slides. So here, third part is quite simple. It's simply about how to properly organize our layers and our layout elements together. And here are some examples of well-designed but simple map layout. You can see that at least we should have titles so that our readers can directly know where's our study area. And then we should add some legend for our map so that they can tell the meaning of the symbols we designed in the map. And also we need to add elements like scale and north arrow as well. Here's a list for all the necessary elements for layout. You can see it includes the map body, the title of the map, legend, scale, direction indicator, which usually should be north arrow, and also you should add some text information about the coordinate systems you are using, and the author of the map, and the map data you used for the project. And here's one thing to remember. To design your layout in SuperMap iDesktopX, first, you need to save your map as what we did before, so that you can add that saved map into your layout. And then you can create new layout window, add your map to it, and then add some complementary elements. And finally, you can save your layout design in your software as how you can save your map and as how you can save your map so that you can change it in the future or share it with the others. And also you can export it as image file or PDF file. And so now we would create a layout for our precipitation map here, and we also provide you the metadata we used for precipitation map. And so now let's go to SuperMap iDesktopX. So here we can first close all those map windows and to create our own layouts. There's two ways to do so. The first one is to go into Start tab on the top. And then here you can find under Browse, there is a button called Layout. You can directly click on it and it would open a layout window. Or you can go to Workspace Manager, find the node for layouts, and right click on it, choose New Layout. And it takes a while to open the layout window in the software. Now it's open. So here you can see we have some layout templates. You can use them if you found them useful, or you can design your own layout. If you want to design your own layout, simply click on the first one, Blank Layout. And now it has opened a layout window. Now it's unsaved and untitled. You can use the wheel on your mouse to zoom in or zoom out. And we can change the orientation of the current layout. Here, still on the top of the software, you can find a tab that is called Layouts. And on the orientation, and under it, there is a group called Page Setup. And under it, you can set the orientation, the size, and the margins for this layout. So here we would change its orientation to here. Sorry. Okay. Can you hear me now? Okay. So now we would change its orientation for this layout to be landscape. And now you can see that looks better. And then for the size, the default size for layout is A4, and you can change it if you want. Now let's zoom back. And then you can use this pen tool here on the very left of layout tab to pan on this layout window. And then here, our next step is to add the map into this layout. And to do so, here, among all those tabs, we need to find a tab that is called Object Operations. Click on it. And under it, we can see on the left, there is a large group called Object Join. And here, we have an option that is to draw maps. Click on it, and here we can see that we can add map objects in different shapes like traditional rectangle or polygon or ellipse or circle. Here we would choose the traditional rectangle. Click on it, and then you can draw your map. You can draw the map. You can draw the map project in this layout window. So here, I would just draw it. Okay, click again, and here you can see the software would ask you which map you have saved among all the maps we have saved. which one you want to put into this map body. So here we can select from all the maps we just created, and we would put Precipitation Map into this map body and click OK. And now you can see it's already added to it. But and we can here now we can use mouse to adjust the location of this map object. If we use the wheel of our mouse to zoom in and zoom out, now we're zooming and zoom out in the whole layout window. But here we can see in the map body, we cannot see the full extent of our map, and we would like to zoom in. We would like to zoom out a little in this map specifically, and to do so, we need to go to the layout tabs, and under it, we can find that there is a group that is called Map Operation, and under it, there is a button called Focus Map. If we click on it, then we go back to layout window and we zoom in or zoom out. Now we're changing the extent of the map. So you have to click on Focus on Map, then you can zoom in or zoom out in your map, in this map body. Otherwise, if I click on Focus on Map again, and now zoom in or zoom out, now I'm zooming or zoom out in the whole layout window. That is a skill you are often going to use when design the map when design your map body in the layout. So now I'm satisfied with this extent, so I can go to the next step. The next step is to add the title of this map, so that the readers would know where are our study areas and what are we presenting. So here, we would go to Object Operation tab, and under it, under Object Join, here we would like to draw text, and we would draw simple text, and click here. Just by one click, then you can input the title of your map. And here, I would set the title to be Annual Precipitation in Southeast region of Brazil, and then switch to another row. So that is to be the factor used, factor for landslide susceptibility assessment. And now, once you complete on input, then you can go to layout. Then you switch to the layout tab and click under browse, click the tool called select. Now you can select on this text feature and move its and change its position by drag it. Now we'll drag it to the center, the top center of this layout, and then now we can see that the size of the text here for the title is kind of small. If we want to make it, if we want to make it larger, then we can select on it and then right click on it, then choose properties. So here on the right, you can see that now we can set the properties for this text object. So here you can see that under text, you can still modify the content of your input. And also here I will keep it and I will change the font for it and also the size and also its size. I would set it to be 36. That's too large. Then maybe 25. Well, that looks okay. And then under font effects, we can set its alignment and that to be center and also make it bold. Now that's how we would like the title to be looks like. So now the next step is to add more complementary elements that is associated with our map body, and to add them, still we need to go to Object Operation tab, and under it, under Object Join, you can see that we can add skills, legend, and lost arrows. But now all these buttons are inactive because the software don't know we want to add the skill or legend for which map. So here first we would need to select this map body in this layout layer, in this layout window, and then you can see once we select it, here all those buttons for skill, north arrow, and legend is active now. So now we would do for add the most important element, that is a legend. And under it, you can see we can add normal legend, or we can design the style of the legend all by ourselves. So here we will do the simple work to add a simple legend. So click on it, and then in the map window, we can draw the areas where we want to add this legend. And here, once we finish draw the area, then we can see that then we can select which layers we want to add legend for. So actually, you don't have to add legends for all the layers in the map. You can decide which layers you can decide which layers you want to add the legend for them. So here, first we would add the legend for our uniform layers. That is our weather station and the boundaries of the study area. So simply select on these two and then click OK. Now it is added to here, but it looks very clustered, and we can change its style here. So here on the right, we can see that it automatically opened a window called legend property. And here, the first one we need to change is legend columns. It looks very very clustered if we want to show them in 3 columns. Here we would change it to 1 columns and press enter button. And now it have changed, and we can here in the layout window to change the size of it so that it looks better. And now let's keep it as how it looks like now. And then we can add another legend element to show the information for our Somatic layer. So still, first select this map body in our layout window, and then go to legend and choose legend again, and to draw our second legend element. And here we would only select the Somatic layer for precipitation isoregion and click OK. Now that's how it looks like, because here you can see in the first legend element, we already have the legend text. So here for our second one, we don't need a title for it. So simply in the legend title, we can change it to be precipitate, change it to be manual precipitation. And then we would like to change it to be in 2 columns. And then adjust its size and position. Or it's still a little clustered, so we can change it to 1 column as well. And then adjust the size of it. Okay, that's how it looks like. But here, as you might have noticed in the first legend element, you can see that the name of each of this legend is actually the name of each is actually the name of the name of the layers. So if you want to change the text of the legend, we need to change the name of our the name of our layers. So go to maps and open precipitation layer. And then here we can change the name for these 2 layers. First one is the boundary layer. We would change its name to be southeast. We would change it simply to be state boundaries. And then for the weather station layer, rename it to weather stations. And then right click to save map, and then close it. And now let's come back to our layout window. Here you can see the text in legend layer has in legend element has automatically changed to what we changed. So that looks clear now. And then we would simply add the scale and north arrow for this map. So first, still we need to select it, and then switch to object operations. And now first select scale, and then we can draw the scale element. We can draw it in the map window or outside the map window. Either way, just as you wish. So here I would like to draw it in the map body. And now we have added the scale for it. If we right click on it and choose properties, here we have open scale property, and we can change change its style. Maybe I would prefer this one, or you can change it to simple lines. And also you can, let me see, change the division width or its interval. Like I would like to be 200. Now that's how it looks like. And then still select our map window, and then go to object operation. Then we can add our north arrow. And here I would still draw it in the map body. And now once you have completed, also on the right, we have the window for north arrow property. If you don't have it open automatically, you can right click on it and choose property to open this window. And also you can change its style. And if there's rotation for it, you can set the rotation angle. So that's all the basic elements you need to add here. And as we said before, we need to add some basic information about the geographic coordinate system you used for this map, and also the metadata and author of this map. And to add them, you can simply add more text element here, and then just type in those information. Like here, I will type in the coordinate system. And that should be WGS 1984. And that's it. And now I would put it to a proper location. And also for more information for metadata of this map, we have provided you in materials for the fifth session. Here we have a text file that is called metadata. You can open it and simply copy it, and then add a new text. And here in this layout window, add a new text object and paste the information, so that you have added the metadata information to this map. And finally, here you can go to slides, referring to all the steps we have done. And here also we have an example of how your final finally your layout should look like. And then our next step is to save it. It's easy, just go back in the software, under layout window, right click, then we can save the layout. Here, simply name it as map layout and click OK. And here we can see in Workspace Manager, under layout, we have saved it. And then if you want to export it as image or PDF file, then you can go to Layouts tab, and under it, you can see that on the right, there is group called Output. Here you can choose to export it to PDF, to pictures, or to PDF file. And if I would like to export it as PDF file, and then here we can set its resolution. The unit for it is dpi. The higher it is, the better it looks like. Here I will set it to be 180. And here I will navigate to where I want to save it. It's similar if you want to save it as PDF file. So that's all you need to know for today. As always, you can refer back to our slides, and here are the quiz for this week. If you have more questions, raise them in the chatting box. And if you don't have questions, have fun today. Have a good day.